Okay, welcome to one of our restoration projects, Digital Equipment Corporation PDP-8 computer. This computer launched on the market in about 1965, but this particular one with serial number 351 was produced somewhere in 1966. We have been working on this for some time now, restoring the power supply, and now we got to try the machine running. When we did that, we found that some parts of the memory addressing was not correct and the memory currents was off, so we had adjusted this. But first we do a little overview of the machine here, so you can see the internals of this machine. Down here we have the power supply of this unit. It consists of fairly big arrays of capacitors for the minus 15 volts and then also in the bottom for the plus 10 volts. And here are the outputs. You also have outputs for memory currents, memory voltages, which is much higher voltages to drive the memory system. There's a big iron core transformer over there. This is the processor side of the machine with all the red flip chips. Zoom in here. For example, here we have one flip chip. Looks like this. This particular flip chip is for the PCMA registers, the memory buffer registers as well. So you have all the transistors and all logic to deal with memory address, memory buffer and program counter on one single chip. 1 bit per flip chip. On the other side you have the memory part of the machine. The black box on top is the actual core memory module. And over here, those with the wires, the green boards with the wires, is sense amplifiers for the memory module. And those that is marked G208 is the inhibit drivers. And here are the XY drivers boards. Then we have the logic for the memory part. Okay, now let's try to start this machine. So now it's running here, you see all the glowing lights. Or not really running, but at least it's started. And we do a load address. Then we try deposit some things into memory. Sometimes the instruction decoding is not correct. It should do DCA, but sometimes it do A and D instruction instead when depositing, which is wrong. So there is something weird with the instruction decoding. So now we have deposited 7777 octal into memory. Let's see what we got there. Do examine. Alright, we have things here. As you can see, we're missing one bit. Bit number 7, 1110.987 is missing. And we have concluded that this has to do something inside the memory stack. We don't know really where, but this is something we have to look into. But after we fix the memory address register one flip chip, the addressing works right, and then also the memory card, so now we can store information in memory except for the bit 7. So the next step is to take apart the core memory module and try to find a problem. Hopefully it is a solvable problem, but we will see that later on. Now we have taken apart the core memory module, and we have attached test leads to our multimeter on the sense amplifier winding right here. And unfortunately our meter gives a reading of infinite resistance, and we actually also check directly on the solder tabs over here. You can see here where it's connected. So we have also tried here, and still we have infinite resistance, which means that something inside this core memory stack is broken, and sense winding is going through all the 4096 cores of this plane here. So we need to find it where it is broken and try to repair that. And before that we also need to take the core stack apart, which means that all these small solder, the stacks are soldered together here and here. So these has to be desoldered here, all the solder has to be taken away and moved. And just then can we take the stack apart and get to the stack that we need to repair. That will be quite complex job. But that's the only thing we can do, because without this stack we can't really do anything. So what we have more here is, I'd like to show maybe here, is this, which is one of the sense amplifiers, which does the sensing. And this is the inhibit wires to the inhibit drivers in the machine itself. And here is the connection to the XY drivers. So what we need to do now is to gather the right equipment, a microscope, good tweezers, and also some courage to actually dig into this core stack and try to repair it. So here you see the 12 planes, 1 bit per plane. Each plane has 4096 cores in a 64 by 64 matrix. And as I mentioned, it has one X, one Y thread through each core, and also one sense winding through each core, and then also an inhibit winding. So it's a 4Y core stack. The good thing with this is that the cores are slightly bigger than those that are later. The 3Y core stacks are
much smaller. So with some luck we can repair this stack to operating condition.